A chemical explosive has the formula C5H8O12N. What is the pressure exerted if 0.500 grams of the explosive reacts by the reaction below in a volume of 1.75 centimeters cubed at a temperature of 255 degrees C? And here's the formula. Let's start by writing down what we know. We know the volume is 1.75 centimeters cubed, which we will use dimensional analysis to convert to milliliters, and then from milliliters to liters to get 0.0175 liters. We know the temperature, which is 255 degrees Celsius, and we will add 273.15 to find the temperature in Kelvin, which is 528.15. And we know the mass of the explosive is 0.500 grams. First, we have to find the moles of C5H8O12N4. So we will start with our 0.500 grams of C5H8O12N4, and we will use its molar mass to convert it to moles to get 0.00158 moles C5H8O12N4. Now in step 2, we're going to find the moles of each gas product that is made. So first, for each of these, we're going to start with 0.00158 moles C5H8O12N4. And then, for the first one, we'll do CO2, and we will use the ratio of 1 mole C5H8O12N4 to 3 moles CO2 to get 0.00474 moles of CO2. For N2, we will start with our moles of C5H8O12N4 we got before, and use the ratio of 1 mole C5H8O12N4 to 2 moles of N2 to get 0.00316 moles of N2. We will use, to find gaseous H2O, we will use 0.00158 moles C5H8O12N4, and we will use the ratio of 1 mole C5H8O12N4 to 4 moles H2O to get 0.00632 moles H2O. Finally, for O2 gas, we will use 0.00158 moles C5H8O12N4, and we'll use a ratio of 1 mole C5H8O12N4 to 1 mole of O2 to get 0.00158 moles of O2. Now we will add all of the moles to each other, so we will add the moles of CO2, N2, H2O, and O2, because we know we are looking for the total pressure, so we can add it all together and use the total moles in our next step. So after we add those all together, we get 0.01580 moles total. Now in step 4, we will find the pressure total, which we know PV equals nRT. If you rearrange it to find P, you get P equals nRT over V. So we're going to implement our numbers. We're going to put 0.01580 moles times R, which is 0.0821 liters times ATM over moles K times 528.15 K, and all of that divided by 0.00175, which equals 391.5 ATM, and because our significant figures means we can only have 3 sig figs, we have 392 ATM total. 13.3 milliliters of an unknown gas diffuses through a pinhole in 1.11 minutes. 9.33 milliliters of chlorine diffuses through the same pinhole in 49.2 3 seconds. What is the density of the unknown gas at 229 degrees Celsius and 347 mmHg? First, let's write down what we know. And we know quite a bit. We know that the temperature is 229 degrees C, and we'll add 273.15 to find it in Kelvin, which is 502.15 K. We know the pressure, which is 347 mmHg, which we divide by 760 to get 457 atm. We know the rate of X is 13.3 milliliters per 1.11 minutes, which we will divide by the 1.11 by 60 to find 66.6 seconds. So now we know that the rate is 0.120 milliliters per second, and the rate of Cl2 is 9.33 milliliters divided by 49.3 seconds, which is equal to 0.189 milliliters per second. And from the periodic table, we can find the molar mass of Cl2, which is 70.91 grams per mole. For step 1, we will use the formula we know, which is, rate of Cl2 over rate of X equals the square root of molar mass of X over molar mass of Cl2. To get rid of the square root symbol, we will square both sides, meaning that we have to square whatever number we get on the left, and we can just get rid of the square root symbol on the right. Then we will use our rate of Cl2 divided by rate of X, and then we will square that, and that will equal molar mass of X over molar mass of Cl2, and it's easier to do that step first, and then we can rearrange it to find molar mass of X, which means we have the 1.575 squared times molar mass of Cl2 equals molar mass of X, and then we will do the square, which is 2.481 times, and then we will plug in the number we have for molar mass of Cl2, 70.91 grams per mole, and that will equal a molar mass of X. And then we will solve for molar mass of X, and we find that the molar mass of X is 175.9 grams per mole. Now for step 2. First, we have to find the formula that we're going to be using. We will start with PV equals nRT, which if we change moles, change moles to what it is, we get PV equals GRT over molar mass, G of course standing for grams, and for molar mass we'll put down mm, and then we have to, so P equals grams over volume times R over RT over mm, and then to find the density of X, which would be G over V, we have pressure times molar mass over R times T. And now we can solve for the density of X. We'll start by plugging in pressure, which is 0.457 atm, and then we'll plug in the molar mass of X, which is 175.9 grams per mole, and divide that by 0.0821 liters atm over moles K, which is R, and then we'll multiply that by our temperature, which is 502.15 K, and when we solve for that, we get 1.949 grams per liter, and because we have 3 significant figures, which means the density of X is equal to 1.95 grams per liter.